and welcome to our video on the coefficient of determination. We've already looked at Pearson's R as an estimation or to show us the strength of the relationship between two variables. And what we find is that when we know that two variables are associated, we can estimate the value of one variable when we know the other. So this is the example I have copied. If we know that the amount of time spent training is associated with the time taken to run 100 meters, so you'd expect if you spent more time training, it would take less time for you to run, so you'd run a faster time. So it's a negative association. And what we're saying is if we know how long someone spent training, so if you just had another person and you knew they spent this long training, you could estimate that their time would be somewhere in between these two dots, and you'd estimate it was in the middle. So you can do that with a lot of accuracy. The problem is, though, how accurate will it be? So Pearson's R can help us see how confident we are with our estimation. If we have an R equals -1, that would be a perfect negative association. So all the dots are on a line. Then we can make an exact prediction because we're just picking another dot inside and we would be exactly perfectly right on the line. A lower value for R, though, will give us a less than perfect prediction. So this one, for example, we're going to be predicting somewhere in the middle here, but you could get, and you could even get an outlier. You might get someone who's really slow at running even if they've trained for this amount of time. The coefficient of determination tells us the percentage variation in the response variable that's explained by the explanatory variable. So it's worth jotting that sentence down because you will use it in your explanation. It uses the symbol R squared and is calculated by squaring Pearson's R. So you calculate Pearson's R first and then you square it using your calculator and you get the coefficient of determination. Here's an example, and this is this example I've got up here. If R equals -0.82, so it's a strong negative correlation, R squared, using your calculator, would be -0.82 squared, which equals 0.6724 to two decimal places, 0.67. This 0.67 tells us that 67% of the variation in time to run 100 meters is explained by the time spent training. So all I've done is I've taken this sentence here and I've inserted the percentage, the response variable, and the explanatory variable. So you'll probably need to do that when you are interpreting the coefficient of determination. What it also means, and you don't need to write this, but I'm just explaining it for you, the other 33% is explained by other factors. Could be their general health, the weather on the day, the lifestyle of the person, their weight, things like that. Now remember, you can use your CAS to easily find R squared. It's on the same window as R, Pearson's R. Or if you're given R, you can just square it and you'll find R squared. You don't need to go through and fill in all the information on your CAS to do that. You could also use r squared. If you are only given r squared, you could work backwards to find r. And the way you would do that is to follow these steps, and there'll be an example after this. First step is to write r squared out. Then you need to find the square root of what r squared is. Don't forget to add a plus and a minus, and I'll show you what that looks like in a moment. Check the scatter plot to decide if it's positive or negative, and write the final value of r. And here's an example of how we might use these steps. The coefficient of determination equals 0.649 for the following scatter plot of data. Use this to find the value of Pearson's r. First step, write out r squared. R squared equals 0.649. Find the square root of both sides, so we get r equals the square root of 0.649, which equals plus or minus 0.806. Now I've put the plus or minus there because when we are square rooting a number, so let's just take us back for a moment. 5 squared equals 25. So the square root of 25 equals 5. But negative 5 squared is negative 5 times negative 5. Negative times a negative is a positive, so that would be 25 as well. So these 5 or negative 5 squared equals positive 25. So if you are going backwards, the square root of 25 could be plus or minus 5. So whenever we're square rooting a number, we need to write that it could be either solution. And the way you do that is write this little plus minus on top of each other at the front to show that it's either solution. Now we're looking at r, which is correlation coefficient. And we've got the scatter plot here, and we can easily see this is a positive scatter plot. It's not negative, it's going up towards the right hand side, looks like positive. So that means we can discount the negative value here and say r equals positive 0.806. If it was a negative looking scatter plot, we would accept the negative solution. When you do that, when you do this last line, you need to write a little explanation about why you're doing that. Because scatter plot is positive. Thanks for watching the video.